We learned about circles and we learned about ellipses in Sparks's notes, but for whatever reason, he didn't include hyperbolas. Now you may be thinking, well, why didn't you teach them then when we did those, when we did ellipses and circles? Because they weren't on the test. And I didn't want to throw this in there then. They may be on the ACT. They absolutely may be. Now, hyperbolas are just strange. You have seen hyperbolas. You just may not have known what they were. Hyperbolas look like this. Whoa, not like that. I don't even know what that is. Hyperbolas look like this. Or hyperbolas look like this. Hyperbolas transformed can even look like this. Now, they do have a line of symmetry. Okay? One way, or one real life example that I can give you for a hyperbola is Halley's Comet. Comets travel in a hyperbolic manner. Here's the Earth. Those comets will come in from deep space. They go around and then they slingshot back. Okay? They follow a hyperbolic path. Astronomy, yes. Astronomy, yep. You know, maybe, don't ignore that dot. I don't know, maybe if you pushed them far enough around the Earth, and maybe they could come back together on the other side. No, it's not an ellipse. These two pieces do not touch. Now, how does Halley's Comet? Because the Earth is round. That's why Halley's Comet will come back, because the Earth is round. But don't worry about it. If you want to learn more, you take astronomy, because that's all I know about it. Okay? That's all I know about it. Now, there is a lot of stuff that you can learn about hyperbolas. Shh, we are not going to worry about all of it. There are things, radar systems. There are radar systems that work on a hyperbolic pattern. We're not going to worry about it. What we're going to talk about is the geometry of a hyperbola, translations. We are not going to talk much at all, just a tiny bit about the eccentricity in orbits. And the reflective property, we're really just going to read a little bit about those last two things, just to get you just a little bit of background. Hyperbola. There are some pictures in your book to explain that number one, because I know that makes no sense. But we can look at some pictures. We just are not going to do that right now. I'm going to tell you that there is way more in these notes than we can accomplish in a day. So there's some of it I'm going to leave out. Okay? All right. I figured you wouldn't mind. The first thing I want to do is go back and review ellipse. Okay? I'm going to draw an ellipse, and I get to cheat. I didn't want to do it that way. Wrong one. I get to cheat as long as I do it correctly. There's my ellipse. Something wrong with your water bottle? No, it's all right. I don't care. You remember, pretend this is, that's your major axis, the horizontal. Do you remember what those points are called? The vertices. Good. Those are the vertices. Do you remember the distance between the center and a vertex? What do we call it? A. We call it A. Remember what that point's called? The covertex. Good. And what did we label the covertex? Yeah, that distance was B. And then we have a focus, which sits here. And the distance between the center and a focus is C. What is the relationship between A, B, and C in terms of Pythagorean theorem? Good. B squared plus C squared equals A squared. These three definitions, well, B doesn't make any sense in a hyperbola. A and C mean the same thing on a hyperbola as they do on an ellipse. What is the definition of a hyperbola, of an ellipse? I'm going to show you what the definition of an ellipse is. Suppose that I put a nail right there, and I tied a string around it. And I tied the string, yeah, and then I tied the other end of the string to a pencil. Okay. No, I don't tie it to the center. I'm an idiot. Here's a little spaceman, doesn't he? My foci. Right there. If I tie a string to each of those foci, and then I put my pencil in it and pull it tight, okay? So my pencil is sitting right there. So these strings are tight. And then I just start moving that pencil around and keeping the strings tight. There's no slack in the strings. That makes an ellipse. It really does. You can try it at home. Now, I'm going to call this right here D1, the distance between that focus and that point. And I'm going to call this length here D2. On an ellipse, if you add D1 and D2 together, that is always the same thing. Well, it ought to make sense. The string's only got one length. That's the definition of an ellipse. D1 plus D2 is always the same. So if I put a point right here, the distance from here to here plus the distance from here to here is the same as it is on the red one. So what the crap is a hyperbola? You're welcome. We're going to ignore this right now. I'll explain it in a minute. Let's look right here. We have our two vertices. Let me draw it bigger so Cameron can see better. I've got two vertices. There's a vertex and there's a vertex. Now I have my foci. What do you notice is the first difference between I'm laying out a hyperbola and an ellipse? Look in an ellipse. Do you see the foci are closer to the center than the vertices? It's backwards on a hyperbola. The vertices are closer. Oh, wait. What's the distance between the center and a vertex called? A. What's the distance between the center and a focus called? C. So on a hyperbola, I didn't want to use that as purple. On a hyperbola, that's A, that's C, which is bigger. C's bigger on a hyperbola. We're back to A squared plus B squared equals C squared on a hyperbola. Yeah. You're like, don't see a B. You will, just not yet. So, we have a vertex and we have a focus. Now, the center is halfway between the vertices or halfway between the foci. This line that the foci and the vertices lay on is called, this term right here, it's called the focal axis. The focal axis. Some people like to think of hyperbolas as looking like two parabolas. They're really not parabolas, but I can see why people would think that. A focus is always inside the branch of the hyperbola. A hyperbola has two branches. That's a branch, and that's a branch. Okay? So a hyperbola has two branches, and the foci are inside the branches, just like a focus is inside the parabola when you learn about parabolas. All right. In an ellipse, if this is true, what's true on a hyperbola? Okay, I'll blow it. I don't know why that does that sometimes. Probably just to make me crazier than I am already. Okay. I'll draw this bigger, Cameron. All right. If I draw a hyperbola, and I put a focus right here and a focus right here, I'm going to put a point on my hyperbola. Oh, that's terrible. I'm trying to draw a line between that point and the focus, each one of them. You're right, I do. I forgot. Oh my, I forgot. If I call this distance D1 and I call this distance D2, what's true about a hyperbola, and this is going to blow your mind a little bit, the difference between those two is constant. If I subtract the length of D1 minus the length of D2, that's going to be the same for any point I could draw on my hyperbola. Do you have to worry about that? No. That's just the definition. If you go to the next page, you will notice a lot of space. That's because in my perfect world, we would actually derive the formula for a hyperbola. We don't have time. That would take 20 minutes by itself. If you ever just are dying to know where the equation of hyperbola came from, you come see me, I'll go through it with you. Okay? Or look in the book. It's there. But we don't have time in class. So I didn't figure you would complain about that too much. I figured you wouldn't complain. The formula that you're going to get out of here is for a hyperbola that opens left and right. Do you remember in an ellipse, the formula looked like this? Remember? In a hyperbola, it's this. You find the center in the same way you found the center on an ellipse. You're going to do your A, B, and C using A squared plus B squared equals C squared, the one that you like is more comfortable to you. Now remember, A is the distance from where to where? Not a focus. Center to a vertex. Center to a vertex is A. It's all right. It's all right. There's a focus. Distance from the center to a focus is C. No. Let's work through some. I'll show you. All right. Now we're going down to your number 5. This equation, the one that I just wrote down, is what we call standard form of a hyperbola with the x-axis as its focal axis. If you have the y-axis as the focal axis, the equation is going to look like that. Do you see how they are different? If your hyperbola opens to the side, it's going to start with x squared over a squared, all right? Well, let me say this. It's going to start with x squared over. If your focal axis is vertical, which means your hyperbola branches open up and down, then the y squared is going to come first, okay? Remember, in an ellipse, it didn't really matter which one came first. The issue was which denominator's bigger. That is not an issue here. Now, I probably want to keep that. This vocabulary. The line segment with end points on the hyperbola is a chord. The line segment with end points on the hyperbola is a chord. That is the chord they're talking about, right there. That piece, the chord lying on the focal axis connecting the vertices, that piece is, we're going to call it the transverse axis. Where did transverse come from? Don't have a clue. This ought to make sense to you, though. That chord is called the transverse axis because it connects the vertices. Okay? Now, what is the length of that blue highlighted segment? It's 2a. That's what it says right here, 2a. All right. The line segment of length 2b is perpendicular to the focal axis and has the center of the hyperbola as its midpoint. That's called the conjugate axis. What the crap? Whatever that b is, right there, you'll take the square root of this b squared. So whatever that b is, that's the length. That's a particular length right there. That length is b. B is not even a part of the hyperbola, but I'll show you why it's important in a little bit. That piece is called, let me see here. There's so much to a hyperbola, it just can kind of make you a little crazy. This distance right here is called b. Ugh. If you put the other b down here, that whole yellow piece is called a conjugate axis. Why conjugate? Don't have a clue. What is the length of that conjugate axis? 2b. Now, as useless as this sounds, this length right here is called the semi-conjugate axis. That's in your notes there. And this is called the semi-transverse axis. Now, your head is probably hurting already. Not yet? Okay. A hyperbola has asymptotes. Why don't you look at this? A hyperbola has asymptotes. Holy smoke. Holy smoke. How can we find the equations of the two asymptotes? Well, what we do is we're going to just substitute a 0 in for that 1. So we're going to write x squared over a squared minus y squared over b squared equals 0. And we're going to solve that equation for y. How would we make that say y equals? Good. I'm going to get y by itself. I heard move x over. I can do that. Or I could move the y stuff, couldn't I? Would it matter? I'm going to have y squared over b squared equals x squared over a squared, correct? We okay there? If I subtracted x squared over a squared, then I'd divide both sides by -1. Or essentially, I just added y squared over b squared to both sides. Yep. Yep. How do I make that say y equals? I could multiply both sides by b squared. Okay. So that would give me y squared equals let me just do it this way. What now? So y equals? What's the square root of that? Bx over a. But what'd you forget? What? Plus or minus. Notice that I pulled the x out of the fraction. A and b are numbers, right? A and b are numbers. So the b over a tells me the slope of the asymptotes. Oh my gosh. Okay. This, let me see where this is in your notes. Go to the next page of your notes. Now, I want you to look at this list. This is just characteristics. When your hyperbola has a center at the origin, and the sides open, the hyperbola branches open left and right, then the x squared leads, okay? And look at the equation of your asymptotes. It's plus or minus b over a times x. Now, I can go through more explanation if you need it, but we're pushing it to get through this. If your branches open up and down, you lead with y, and your asymptotes are plus or minus a over b times x. Now why is that? Why is the difference? If you look in this one, do you see that the b is under y? And in this one, you see that a is under y. So if you solved them the same way I solved them before, you would get this since the a is under the y. Okay, now. Let's go down here to example 9. Now we're going to work this one, and then we're actually going to draw it. That's why I gave you the rulers. So let's look at number 9. Find the vertices and the foci of that hyperbola. Look at the form it's in. It's certainly not in a good form for us, is it? What do we need an ellipse and a hyperbola to equal in the equation?
1.
How do we make that equal 1? Good. If you divide every term by 36, what are you going to get? X squared over 9 minus y squared over 4 equals 1. Does the x squared lead or does the y squared lead? X squared leads. So is this, are the branches going to open horizontally or vertically? Horizontally. Good. So I want you to just make yourself a little, I'm going to go down here just so I'll have more room. Just make yourself a little graph. Where's the center of this hyperbola? At the origin. Good. Center's at the origin. Does either branch of the hyperbola contain the center? No. No, the center is not actually a point on the hyperbola. What's A? Look back up here. A is always first. B is always second. So A is 3. B is 2. Can we find C? A squared plus B squared equals C squared. Good. What does C stand for? The distance center to a foci. What's A stand for? Center to a vertex. All right. Where are my vertices? How far? Yeah. So how far? 3 both ways, right? 1, 2, 3. 1, 2, 3. There are my vertices. So my vertices are at there. You okay? Where are my foci? Where are my foci? Think about it. We need to use square root of 13. Okay? Yes. Because isn't the C the distance from the center to a focus? So the distance from the center to the focus, and Malin said that's just a little bit less than 4, right? Yes. So the foci are right in here somewhere, but their coordinates, as Lily said, they're the foci. Now the question is, can we draw this beast? Of course. Of course we can draw this beast. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, and we said that there were the vertices. Now, go back right here. What are the asymptotes of this hyperbola? Plus or minus b over a times x. Well, what's b over a? 2 over 3 or 3 over 2? 2/3. Your asymptotes are y equals plus and minus 2/3 x. Is there a question? It's Friday afternoon, I know. Now what you're going to do with your pencil, you're going to use a dotted line. A dotted line. You are going to draw these two lines on your grid. What's the y-intercept? 0. Let's take the positive one. Rise. Up 2. Don't say over, say right or left. Up 2, right 3. Well, there you go. Up 2, right 3. Up 2, right 3. There's an asymptote. And then we do the negative 2/3 x. Up 2, left 3. Up 2, left 3. Well, your y-intercept is the origin, so yes. Please use your ruler to draw that line segment. And please make it a dotted or dashed line because those asymptotes are not part of the picture of the hyperbola. And now you say, how do I draw the hyperbola? You're going to start at that vertex. You're going to come out, not yellow. We're going to come out, we're going to hug that asymptote. We're going to come out, we're going to hug that asymptote. Over here, from the vertex, hug that asymptote. Hug that asymptote. And there's your picture. That wasn't too bad. That was a lot of work. Do you notice that B, the only purpose of B is to help us draw the graph? I'm sorry? Yeah, and so here's the issue. Does C is actually part of one of the branches? No. But I know my C is in here somewhere, right? Okay, let's continue. I think we've got a number 10 there, right? Okay. Number 10. Oops. Number 10, find an equation of the hyperbola with foci at 0, -3 and 0, 3, whose conjugate axis has a length 4. Sketch it along with its asymptotes. Okay, that's a lot of crap to do. Plot those points, plot those foci. Are the branches of this hyperbola going to open right and left or up and down? Why up and down? Because my foci are vertical from each other. Yep. So which formula will I use? I'll use the second one. I'll lead with y squared. Y squared over a squared. I'm going to write that down so I don't forget it. What do we know about any of those variables, a, b, c, right now? C is 3. Because c is the distance between the center and focus. Good. Now I'm right here. What's that? Go back and look in your notes. Is the conjugate axis the one that goes through the foci or the other one? It's the other one, right? It involves which variable? B. The conjugate axis has a length 4. By the way, where's the center? How do you know the center is at the origin? Good. Midpoint between the foci. Good. So if the conjugate axis has length 4, what's B? 2. Good. Now, I'm sure something pretty cool here in a minute. I'm just going to put a little mark right there because I know B is 2. Okay? Just a little mark. What else do I need to know? Oh, you said B is 2. A. How am I going to find A? A squared plus B squared equals C squared. A squared plus B squared equals C squared. What's A? Square root of 5. Good. What does A tell us? A tells us the distance between the center and vertex. Square root of 5 is about a little more than 2. So I got a vertex right about there, a little more than 2. Can I write the equation? There's my equation, and I've got my A and my B. So what's the equation of this sucker? Y squared over 5 minus x squared over 4 equals 1. That's the equation of my hyperbola. Questions there? So you've got the equation. Now what we want to do is graph it. Now let me show you something. I could sit and write the equations of the asymptotes, right? What are the equations of the asymptotes? Plus or minus a over b times x. So what is that? Well, my asymptotes will be y equals plus or minus a over b times x. Yes? Watch this. My a is at these purple points, correct? My b is at these yellow points, correct? Prepare to be amazed. Okay? Let's get a new color. Let's get orange. Tan. Tan is like blob, but all right, tan. Watch this. I'm going to draw a rectangle. I'm going to draw a rectangle, and I'm going to make the rectangle this wide and this tall. So I'm going to go like this. You see where I made my rectangle? I used my A length and I used my B length. And I just drew a rectangle. Now look at this. Look at this. Your asymptotes are the diagonals of that rectangle. Sorry? Well, then you just can't hold a ruler in the right place. No, I'm My apologies. That was not meant to be rude. It was rude, but it is are your branches opening up, down, or left, right? Up, down, so you're going right in here and you're drawing that hyperbola, hugging those asymptotes. Oh, you know what? I screwed that up. Heck yeah, I'm not supposed to make it go through the focus. It goes right there, doesn't it? You probably did it right. Goes through a vertex, doesn't go through the focus. Let's talk about the box that we drew. Thank you. Your box should be pretty as well. Here's my question to you. What is this height right here? Distance between the center and a vertex is A, right? What's this distance here? B. Didn't we do rise over run? That's why I can just draw the box. Rise is A, run is B. Okay? If you can do what we've done here, you got hyperbolas. Honey, I got so much graph paper. Okay. Let's go on to your number 11. What you see here is when you have a center that's not at the origin. Everything works the same way. I promise. Everything works the same way. I promise. I'll promise, however, promise. When you have to draw one that's not got a center at the origin, drawing that little box is a lot easier. Okay? All right. Remember, if your branches open left and right, you're leading with your X. If your branches open up and down, you're leading with your Y. Okay? All right. Let's give this a shot here. Would you like graph paper or right now, or would you rather be doing this on your notes? I figured notes at this point. Okay. When it says to write an equation, I can't write the equation unless I draw at least part of it. So you're just going to have to suffer through this with me. If you can do the equation without drawing, knock yourself out. I don't care. I mean, I care if you knock yourself out, but don't. Yeah, never mind. Okay. Find the standard form. What'd you say, Lily? Find the standard form of the equation for the hyperbola whose transverse axis. Transverse. Go back in your notes. Is that the one that connects the vertices or the other one? That's the one that connects your vertices. Has endpoints -2, -1, and 8, -1. Plot them. What are those points? Are they the vertices or the foci? They're the vertices. They are the vertices. Where is the center? Where? Midpoint, which is going to be 3, -1. So the center is at 3, -1. Is this hyperbola going to open up and down or left and right? Left and right because your vertices are horizontal from each other. Yeah, yeah. So do we lead with X or do we lead with Y? So it's going to be X minus, what's H? 3. Over A squared minus Y minus -1 squared over B squared equals, we got part of it done. Do we know A? What's A? Why is A 5? Because it's from a center to a vertex. A is 5, so what goes right here? 25. The conjugate axis has length 8. Where's the conjugate axis? Because the conjugate axis is perpendicular to the transverse axis, so it's up and down. So it would be sitting right in here, correct? And how long is that? 8. So what is B? B is 4. So 16 sits right here. And you just wrote your equation. That's it. Said write the equation. We did it. It didn't say to. Now, I need that much of the graph to know how to write my equation. Question. If this was on a multiple choice on the ACT, that would not be the option. The option, no, I mean as far as the equation. If we go back, your option would look like that. Okay? How would you make yours look like that? So what we're going to have to do, calculator, what's 25 times 16? 400? Somebody get a calculator. Get your phone out. Tell me what 25 times 16 is. 400. No. The only reason I was able to do that is 25. I was just thinking there are 4 25s in 100.
16 quarters.
Okay. 25 goes into 400. So 16 times x minus 3 quantity squared minus okay. So I just need you to know that that's how you could get it to not have fractions in it. Are you all right? Okay. Let's look at example 13. If I can get the smartboard to go there and stay there. Come on, be sweet. Be sweet. There we go. Look at your notes for just a minute. We're going to do number 13. Please look at the rest of this. Turn your stuff, okay? The rest of this, number 17, I was already planning to leave out. Do you see that it says on your number 16, it says to read a paragraph? Mark that. Please read that because it's just got some interesting stuff in it about hyperbolas and their uses. No, it's not your homework. Well, it's part of it. Don't even start with me. And then look at number 18. Look at number 18. It says read the last two paragraphs on page 607 and study the figure in the margin. Please. Okay, here we go. Last question. Find the center, the vertices, and the foci of this hyperbola. What's easy to find? Fine. What's the center? How do I know this equation's not an ellipse other than the fact that I told you it was a hyperbola? Yeah, I know it's because that's a minus. If that had been a plus, that would be an ellipse. A is 3. Yes. A is 3. And B is 7. I still need a teensy bit of sketch, and I'll explain to you why I need a teensy bit of sketch. I need a teensy bit of sketch. Oh, shush. Centers at -2, 5. Centers right there. I'm just real visual. I just need a picture. How many of you remember if you had Miss Lashley for pre-AP geometry? Draw a picture. Didn't you hear that a bajillion times? Draw a picture. Okay. She meant it. So do I. It helps me if I draw a picture. Does this hyperbola open left, right, or up, down? How come? X is first. X is first means left, right. Yeah, I know. X is first means it opens left, right. Y is first means it opens up, down. This thing opens left, right. So A is 3. So A is the distance between the center and a vertex. So if I go over 3 and over 3, from that center, where are my vertices? 1, 5, and -5, 5. You all right there? So there would be my vertices. We need to find, we found the center, we found the vertices, now let's find the foci. What's the matter, Eve? A squared plus B squared equals C squared? What's C squared? Okay, let's talk about plus or minus. C is distance, so just plus, yeah. But C is the distance between center and the foci. So my foci are going to be, I got to go out square root of 58 from here, and I got to go out square root of 58 from here. Say it again. -2. Well done. Good. Those are the basics of a hyperbola. I do want to encourage you to read those couple of paragraphs in the text because there are some interesting things about a hyperbola we just don't have time to address, especially since I have duty. Your assignment is at the bottom of your notes, is it? Now, do you see the part that says 24 through 42 multiples of 3?
Yeah.
Can you do that? 24, 27, 24, 27, 30, 33, 36, 39, 42. All right. Odd answers are in the back. I'll give you the even answers next time.